Yeah. This is Loco No, the smart table. Kind of taking a step backwards, actually. He fell off the table the other day from the sit side. If this is kind of picking up where George left off. Did we win? Did we win?
Yeah.
You're world champion San Francisco Giants. Yay! All right. And
is that why you painted Loco orange?
so if you put on your telescopic vision, you can see the little dots on this RViz. RViz is the visualizer for Ross robot operating system. I want to see if I can actually plug in this computer and get it on the screen. Okay, I've got it plugged into the computer. Is there any way to get it to this screen?
I didn't do anything last time.
Function screen. Let me see what
I have to figure out how to get it back.
Function screen. Anything? Not today. Function screen. Anything? Hey, Steve, what's the trick? Oh, did you use? Are you using the Mac? Is it this one here? Let's try the other one.
Oh, yep.
Hello? Anybody home? Well, that was...
Last time it worked, both screens went off. Switch.
Yeah, okay. Regardless, all I wanted to show is RViz working with the Nito LDS laser distance sensor. And again, I think the Nito is one of the best Ross trainers around. Oh, this is the smart table. The concept is a table that can get from one place to another and back again. And that's all. Thank you. Hey, Mark, good to see you. I'm Tom. Tom, I'm sorry.
Hi, I'm Aton, and I make twisty puzzles as a hobby, crazy Rubik's Cubes. I've been making them for about 6 years now, but various geometries, all sorts of lots of pieces, and it's pretty crazy. But I've had a dream for a while of making a 3x3 solve itself, and I've been working for several years on this. And when I moved out here today, I met Tom, who wrote the program that brute forced the cube a few years ago. So that was a pretty nice meeting. And so he wrote the program for this. The two of us have been working on making this work now. And so at this point, hopefully, we're going to, I mean, it uses 3D printed pieces. It has springs and screws and everything like that. 6 geared motors, and uses a Teamsy 3.1 for brain and a bunch of motor drivers and everything like that. And I mean, let's just.
So this is our vision. How many people here can solve this thing? Ah, quite a few. That's nice.
Actually, not very many. I was expecting more.
So what we hope this thing is going to do is they're going to be able to hand this device to somebody, and they're going to be able to scramble it just like this. So it's not on, it's just sitting there, and it's completely inert, and they completely scramble it. And then you put it down on the table, and then it will solve itself.
Knock on it a few times, maybe.
Yeah.
Then it'll start solving.
So it will turn its own faces. It will figure out which faces, which colors are on each face by turning each face in turn once around. And once it's figured out which colors are on each face with little internal sensors, then it will actually calculate a solution algorithm and then execute that solution algorithm with motors internally, sensors internally to know where it's going, et cetera, et cetera. So basically, we need to fit 6 motors in one of these, or something like that. A whole bunch of sensors, all the electronics and stuff like that.
And all that wire cost.
Right. So right now, because we're just prototyping, we're just trying to get this to work. All the electronics are external. All the electronics are external. We got a TNC and one motor driver right now. We're going to have, of course, 4 motor drivers and all sorts of fun stuff. So let's see what happens when I hook this up. Let's see this up. Okay. So here we go. So now it's turning one face, and now it's turning another face, and now it's trying to turn the face. We sort of got stuck a little bit, so we got to figure out a way to solve that. So this is sort of what we're getting at. It's not quite there yet, but you can see it actually turns the faces and everything. These, of course, would be colored faces. It's not going to be an all black tube. That would be
There, it's done.
but
Finished that a while back, yeah.
So he's the mechanical genius. He's designed all these pieces. You've got to see these pieces because I mean
we'll show them off at the when people can walk around. But
these are awesome.
I mean,
that's the core. This is going to hold all 6 motors.
Oh,
all 6 motors.
6 motors, as well as many mounting surfaces for things like mini breadboards, things so that we can eventually we'll solder everything together. But for something like this, we're going to have a lot of debugging to do.
All the electronics, all the control, everything, all the batteries fits inside this thing.
And then outside, we have the pieces of the Rubik's Cube. It has a spherical mechanism because that just works better in 3D printed plastic. I think tricks of the trade. And underneath the mechanism, there are these flat surfaces that I've added so that the optical sensor is so we can put some barcodes on there and kind of make our own encoders using those IR line sensors that we like to use in like line following robots. And Tom has programmed it so that we're working on it so that we can actually identify the colors on the outside based on the barcode on the inside. The idea originally, one of the early prototypes, very much failed prototype, had more of a relative encoding system, so that you could it would record the scramble pretty much. But I discovered that pretty early on that the issue with that is that if anything crashes, if anything goes wrong, it will have no idea where it is when it wakes up. So I would like it to know, no matter what state it's in, once you tell it to start solving itself. So it's using absolute encoding. And yeah, so we're hoping to get this done in the next couple months.
Right. One of the challenges we're facing is, of course, the sensing itself. We're using IR reflective sensors, and they tend to have a quite wide beam. They will actually see anything within like a quarter of an inch or something like that. And that's way good for the fine sensing you need to do.
So if anybody has any experience with these things or experience with a sensor that we just have to see, tell us, please.
Yes. Well, please.
Thank you.
Thank you.
Hi everyone, my name's Kevin. I met Camp a few weeks back, and he also gave me one of these Neato robots. And so I played around with it for a bit, and they're pretty fun. And so I didn't get too much done with it, but I have it just taking in the laser scan data into ROS and generating a map. And so what I wanted to do, my goal was to try to build my own SLAM code, because I didn't want to use the stuff that's already out there. I just wanted to learn what's working behind it. And so I didn't quite get there, but I've got some mapping. And let me see if I can just get that started up now. So I didn't want to turn it on earlier because it's kind of noisy. I don't know if you can see this here on the screen, but that's a rough map being generated right now. So it doesn't do well with anything that's moving. and there we go.
There you go.
So I think right now it's just seeing the edge of the podium there. And yeah, so I'm hoping that once I get the scan matching working, then I can start putting more noise rejection in there, or something like that, and then try and build up the slam notes in there. But that's where it is so far. Thanks.
Okay, so I've got this old tank here, and it I've gotten most of the. It's no longer something that's the pilot parts. It actually at least works. It will just probably fall off the table. So it'll do the same. Just repeat a pattern until it dies. The battery dies. I'll be able to print the concept for it basically. I'm just there's no real software, just the patterns. But at least all the mechanic stuff's done. All the mechanical stuff's done there, and it like actually drives.
Can you bring it back that way?
This is kind of like the same problem here. Like that one.
Does anyone have an internet connection? You guys have an internet connection?
No, it's just doing the same pattern until the battery dies. It's just a test of functionality test to make sure everything actually works. I mean, I can have it working with power supply on the breadboard, running motors and stuff, but until untethered, it's not working.
That's an Arduino.
Yeah, well, actually, it's Arduino. I've programmed an Arduino, but it's just built the circuit. It's a mega chip on there. I had to figure out which Arduino to call it to make the software work, but yeah. And that's about it. There's a lot of more things to be done, but at least now it's something that's not unfinished. Very good. Just check the pastor build program it. USB goes dead.
Really? You did all the wiring on the board?
Yeah, everything's separate.
Good. Good.
Holy. That was 6.5 hour battery.
Yeah, but what's the key? How fast can you get it closing?
Well,
Just 3 seconds. So the lithium.
yeah.
The C rating?
Well, usually the C is the one. 6 It's a 6.5 hours, so you go up to 6.5 hours.
Prototype of a prototype
They're just, that's literally what you're typing on Amazon.
This one is actually
You're going to take a picture of it.
official hardware tool sample from the EP category.
Talk louder, Gertz.
So I kind of built a little scaled down version of the robot that should be collecting samples and bringing them back. So far this is low clearance version for indoors for this challenge, but I guess I need to build it for the grass field. Mars is where we will need to collect the samples.
Grass fields of Mars?
So let's see if this will work.
What a funny sense of humor. He always keeps a straight face when he tells the truth.
Speak much louder.
He doesn't, he can't speak louder. It's great. It's his speed and his tone.
We got to do with samplers, right?
Yeah, so as we have seen in the previous 3 years when they have been running this competition, what they do is the team allows to actually start the robot on the starting platform, and what they do is point the robot in the direction of the person. That is what we will be doing.
He's supposed to recognize the pink ball with the lights, you know, when we're getting these different lights. It's like, I've had this problem over and over. They don't like an 8 IR on these lights. lights. It's always the same problem in everybody. The sensors going to tell you the different lights, and it's like, when you need a laser, when you need vision system. You need a vision system. It's all reaction. You don't really see the color grabs.
That's real weird. It's going to be interesting to see what's up.
Look, it's following away. We walk by and follow them. What?
Is this Floorbot Challenge Phase 2? Serious?
Yeah,
All right.
Something about the grass on Mars.
2.5.
Okay.
No, the Mars Return Challenge qualification is looking at objects and adaptive fields.
Since you've gone back up and running. Yeah, I just figured
Well, it's darker than
you get that autonomously?
I don't know.
Is that autonomous, or are you controlling that? I think that answers that question.
Yeah.
Well, I think he's adjusting with the thing, and then he says go, and then it just goes.
Is this the autonomous mode?
Yeah, so now if I let it go autonomously, yeah.
You can get the arm
I'll pick up pink tennis balls on Mars.
Yeah. Should there be any pink balls on Mars? We're good to
Very
go.
good. This is Alan again, and here's my smarter teammate, Roban. We're part of a project that started 2 years ago called Ubiquity. And the aim of Ubiquity is to design a really low-cost platform that's good for domestic robotics. And the goal was to design a platform with a bill of materials costs for under 500. And we think we're there. So we're using brushless hub motors that we sourced from China. We have a custom controller board. Because they're brushless hub motors, the Hall effect sensors are in there, so the motors are, besides being compact, inexpensive, reliable, have built-in odometry. You don't have to add a separate encoder. So we have a very quiet, very powerful. We estimate it can move around 200 pounds. We're using sealed lead acid batteries, SLAs, and we have several use cases. We're thinking seriously about a Kickstarter sometime in January. And we're close to final design. And this one is just the base shell. So the biggest challenge so far has been navigation. We can't get really good indoor navigation sensors. So it'd be nice if we could get the Nito LiDARs for $40, but we cannot. So we have our, right now we're using a sonar skirt, and we are working on a more advanced room sensor. We also have been, in association with Wayne, working with ceiling fiducials. That's been successful too. But lately, because of SVR with the RTAP map, we may once again switch our navigation. So we have a teleop mode, and right now that's what we were demonstrating on the drive.
So with Power Robot, almost all of the software besides the firmware is all done in ROS, so which is Robot Operating System. So one of the main challenges is that this platform we're using a Redaxa Rock, or maybe we'll move over to a Jetson board, but those are ARM-based architectures instead of the standard Intel architecture, which means that getting ROS to run on it is harder, and it's not. I think the build farm might have ARM builds, but they're not. The ROS build farm might have some ARM builds, but we haven't used those. So Austin Hendricks, which I don't see here, but he made a specialized build farm for ROS and ARM. So if you're, which is part, and because we're using an ARM board, that's how we can get it to meet the $500 price point that we were, $500 bill of materials that we wanted. And because the Daxarock is $99 versus something like a computer is significantly more than that. Usually, usually like a $200 to $300 worth for a low-end Tablebot style laptop. And so the entire thing was done to ROS on ARM, which allows easy coding of the platform and getting it to do whatever task you want it to.
And the goal of this is, you know, the Homebrew Computer Club came out with basically people from here came out with the Apple II. My goal is to have the Apple II equivalent of a personal computer. So as a basic platform, I don't care about the application. Right? We have the basic platform. What people figure out for the application, that's not my department. Thank you.
Okay, so this is Maxwell. Robot I've had around for quite a while. Won the 2011 AAAI chess challenge that they ran, their small scale manipulation challenge as they called it. Recently has gotten a whole bunch of upgrades. Afterwards I'll actually pop the front down so you can see some of the electronics boards if you want to come and find it in the back. But I've recently upgraded from, I had an Arduino based controller in there in robotics since 2011 or so. And this summer I actually switched it over to a new ARM-based processor that I have in there. And I also got rid of, I always have problems with USB dropping out on me. And so the new controller board is actually based on Ethernet. So there's no USB, there's no ground loop problems, all that sort of stuff just goes away. And I've got a lot of bandwidth to connect to all the servos, connect to the control loops down below. So that's pretty nice upgrade. The robot also has on the back here an Intel NUC next unit of computing. So that's their small, it's actually an i3 based one, but their small Intel based computer. It draws only like 15 or 18 watts. And then I've got a step up converter from Huawei on a power board that I laid out inside. So it sort of keeps all the wiring nice and clean. Computer's right on there, you power it up, you go. So it's now driving around, and that's about how far I've gotten back up to. So it's sort of like all the base hardware works. I was planning with getting MoveIt running on it, but I just got the MoveIt stuff to compile on Mac last night, and it's not actually working on my laptop right now, so nothing to show there. And then the last upgrade that I sort of have on this robot was that for a long time I've wanted to build a better gripper. The gripper that's on here is sort of just using two servos that come together, and it's not just sort of moves back and forth here, and so it has a wide grasp, but like you can't hold all that many things. It works pretty well for like a Coke can. It's actually terrible for a chess piece, which I've got like this little 3D printed adapter in there trying to get to actually hold the chess piece. But probably 2 years ago, I had some 3D printed parallel jaw grippers that were really kind of large, kind of clunky. I had to like file them down every time because I was 3D printing like all the parts. But they had this little mechanism inside so that as the servo turned, it would pull both jaws in individually. And recently I found that IGUS makes these really miniature linear bearings, that are dry linear bearings, that are like $4 for like the little mouthpieces, and about $4 to get them to cut a custom length and drill the holes into it. So I've got two of those in there, so there's like $16 to get the bearings, and then some 3D printed fingers and those mount pieces, and then 2 pieces of laser cut, the things then sandwiched together. So I haven't actually gotten this fully finished yet. It got assembled last night, but it's coming along. So that'll be replacing the gripper and the wrist roll. So yeah.
So we were going to do the Connect Challenge robot earlier, and our perennial problem in this club is our batteries kick out on us when we get close to demo time. And so they recharged it, and we'll see if it's happier. So, somebody up here going to talk?
Yeah.
So we ran out of battery during the kind of navigation thing. Just now we've already made a map, set the waypoints. Now we can go back and forth between all the waypoints pretty much automatically. The only trick is it has to kind of first locate itself on the map. That's one of the advantages of our map is that it can localize very well. So it will find that something puts up to the side of the map and all start going. And we don't have more technical difficulties.
All right. Next time.
All right.
Next time.
Yeah.
Okay.
All right. The whole goal of our thing is we did telepresence, and I'm going to try to pick up the pill bottle off the white, or excuse me, yellow chair. Good luck. I don't know if I'll see it or not, but we'll see.
Back up a little bit. Little right. Other right.
Good shot of Cam's back.
No pressure, Carlini.
How's you train?
Now you're trying this the pedestal, man. You gotta take your soul. Oh, you need straight. Yeah, where's the target? No, it's the fellow back in the corner is driving. Captain Zybot, ladies and gentlemen. Loud enough. Yeah, there you go. You guys dancing over there? I don't see you dancing. There we You know what? You have to keep it on the microphone. Worth the price of admission right there, eh, folks? Again, there's some free nuts and bolts magazines here. Big hand for the guy with the crow over there. Good job. Thank you, man. You did a good job.
Okay, as president, I get to go last. So I hope there's no more robots because I'm going last.
No, you're supposed to say the best is last.
I'm not going to say that. So you probably have been hearing the word ROS a lot tonight. How many here don't know what ROS stands for? It stands for Robot Operating System. It's sort of a pretty straightforward, but if you don't know, you don't know. So anyhow, more and more members of the club are trying to get involved in ROS. And right now, the only platform that you can buy that's sort of ready is called the Tablebot Clearpath. Yeah, so it's over $1,000. So I've been working on a project with some other club members to build a lower cost ROS platform. And this is very definitely a work in progress. I'm laying out all the printed circuit boards and working on all of the electromechanical. These laser cut wooden things are in fact going to be encoders and motor assemblies. They're remarkably inexpensive. They'll probably be a parts cost of less than $10 when they're all done. In addition, it's hard to show this, but I'm building a set of modular electronics to drive all of this, so you'll be able to basically start off small and slowly add things to the robot in terms of functionality. So it's a work in progress. You'll be seeing more. The goal is to get at least 5 of these built, probably closer to 10. and get them distributed throughout the club so we can get a little synergy going. So that's about it. So with that, do we have any questions? If not, I actually have a question, which is the last Thursday of November, so last Wednesday of November, the day before Thanksgiving or not? I think it is. It is. Okay. When that happens, we move the Thanksgiving meeting forward 1 week. So be prepared. It's 1 week before the Thanksgiving break is when we have our next meeting. It would be the 19th. So I think that's only about 3 weeks from now. Okay. So 3 weeks from now is our next meeting. That will also, because I'm president, I have to tell you that will be the election meeting. So with that, I hope you all had a good time tonight. And please show up next month and have fun. So thank you very much.